Hello everyone, in this session we are going to see how to draw a influence line diagram and find maximum shear force and bending moment at a particular section due to a UDL moving load. So in this problem we can see that we have to find maximum shear force and bending moment at a section which is 8 meter from the left end of a simply supported beam which has 30-meter span. So where we have a UDL of 6 kN per meter magnitude moving from left to right. So UDL has a running length of 5 meters. So first thing is to find the maximum positive shear force. To find the maximum positive shear force, the main condition is, so due to a moving UDL, see this is a section which is 8 meter from the left end. So to get the maximum positive shear force, the tail of this UDL should be placed at the section. So this is the tail. So it should be placed at the section. So you have to place the UDL like this, which has a magnitude of 6 kilonewton per meter and a running length of 5 meters. So this is the condition. This is how you have to position your load to get the maximum positive shear force. So we know that the positive shear force diagram will be drawn like this. So this is the ILD for shear force. So to get the maximum positive shear force, maximum positive shear force is found by using magnitude of UDL, that is load, into area of ILD, influence line diagram, under the load. So this is the condition to find the maximum positive shear force. So to find the area of ILD under the load, this is your load. So if you project like this is the area of ILD under the load. So this is the shape which is in trapezium. We'll take this as A and this as B and this as height of the trapezium. So area of trapezium is A plus B by 2 into H. So if you substitute A, B and H, we can find the area. If we multiply the area with the load, we can find the maximum positive shear force. So to get the area, we need to find A and B, which are the ordinates. We need to find those ordinates. So this is the maximum ordinate of a positive shear force region, which is L minus X by L. So we can find L minus X divided by L. L is your total span, which is 30, X is 8 meter and L is again 30. So while substituting this, you can get it is 0.73. So this ordinate value is 0.73, which is your A. And this is the ordinate which has head of the UDL. So to find this ordinate, we have to see the proposition of horizontal to vertical. So this is the length which is 30 minus 8, which is 22 meters is this length. So this is 22 meters. If we subtract the running length of UDL from 22 meters, which is 22 minus 5, will get 17 meters. So for 22 meters, we have a vertical of 0.73. For 17 meters, how much verticals? So for 22 meters, we have 0.73 verticals. For 17 meters, how much you will get? So you will be getting like 0.56. So this will be your B. So this coordinate is 0.56. We know the height. So this distance, which is 5 meters. Substituting these values, we will get the maximum positive shear force. So the load is 6 into area, which is A plus B by 2 into H. So we'll directly substitute the A, B and H. So A is 0.73, B is 0.56 divided by 2 into H is this distance, which is 5. So the answer will be 19.35 kilonewton. So this is the maximum positive shear force that we will be getting. So in the next session, we will see how to find maximum negative shear force and bending moment. Thank you.